What is classical physics? Let's start with the easiest, perhaps. What is physics? Physics is the study of the natural world. It's the study of the physical world, the world we live in. It's experimental science, and it's really the heart, the core of all other experimental sciences. Physics goes beyond just a simple description of nature. It's an attempt to unify a broad variety of phenomena that we observe in the world, both the natural world and the technological world. We're looking for the underlying principles, the explanation, the prediction. We would like to be able to really understand the world around us, measurable things in particular. Physics studies matter and energy, space and time, studies particles and waves, forces and motion. These are a lot of words that we use. We have deep intuitive sense about what those words mean. And part of what we're going to be doing in this course is to start looking carefully at each of these words. What do I mean by energy? What do I mean by force? How would I define that in a laboratory and measure it? And what use is it? How does it help me to understand things about the world?
We exist in a world where 30% of people are starving while the planet's human population continues to surge. Our natural resources like water and arable land are shrinking, and pollution and dramatic changes in climate are increasing, all alongside whilst there are concerns about energy use and our food choices. The need for global sustainable and profitable agricultural practices are a recognised imperative. Food security, by definition, exists when all people at all times have physical, social and economic access to sufficient, safe and nutritious food. Although we have a long way to go before a full-blown food security crisis, the consequences of not acting together or acting now are dire. It will lead to global unrest and compromises the well-being of humanity. Together globally, we have to do more with less in more difficult circumstances and act now.
Anthropology is a holistic study of humankind. It studies all the aspects of human life, all geographic regions of all time periods, from its evolution as Homo sapiens to its diverse manifestations within cultures and societies, both past and present. Since recorded history, people have sought answers to such far-reaching questions as who we are, how have we come to be as we are, how can diverse peoples coexist peacefully, and what might the past and present tell us about our future? Anthropology seeks to answer these and many other fundamentally humanistic questions. Anthropology employs both qualitative and quantitative research methods within its numerous subdisciplines. Common to all anthropologists is method of fieldwork. A physical anthropologist may observe wild or captive primates or dig prehistoric sites to discover clues about humankind's origins and early migration patterns. An applied anthropologist plays games with disadvantaged schoolchildren to advise school administrators on how to create conflict-reducing after-school programs. A socio-cultural anthropologist may live in a hut among tribal communities to learn the meanings of their unique rituals and political economy. A linguistic anthropologist interacts with native language speakers at a family function to discover clues to their cultural retention amidst globalizing society.
My talk is on black holes. It is said that fact is sometimes stranger than fiction, and nowhere is that more true than in the case of black holes. Black holes are stranger than anything dreamed up by science fiction writers, but they are firmly matters of science fact. The scientific community was slow to realize that massive stars could collapse in on themselves under their own gravity, and how the object left behind would behave. Albert Einstein even wrote a paper in 1939 claiming stars could not collapse under gravity because matter could not be compressed beyond a certain point. Many scientists shared Einstein's gut feeling. The principal exception was the American scientist John Wheeler, who in many ways is the hero of the black hole story. In his work in the 1950s and 60s, he emphasized that many stars would eventually collapse and highlighted the problems that posed for theoretical physics. He also foresaw many of the properties of the objects which collapsed stars become, that is, black holes. During most of its life, a normal star, over billions of years, will support itself against its own gravity through thermal pressure, caused by nuclear processes that convert hydrogen into helium. Eventually, however, the star will exhaust its nuclear fuel and will contract.
This class today is about language, and language is, to a large extent, where the action is. Let's start with an interesting claim about language made by Charles Darwin. So Darwin writes, "Man has an instinctive tendency to speak, as we see in the babble of our young children, while no child has an instinctive tendency to bake, brew, or write." And what Darwin is claiming here is that language is special, in that there's some sort of propensity or capacity or instinct for language, unlike the other examples he gives. Not everything comes natural to us, but Darwin suggests that language does. Well, there are some basic facts that support Darwin's claim. Every human society has language. In the course of traveling, cultures encounter other cultures, and they often encounter cultures that are very different from their own. But through the course of human history, nobody has ever encountered another group of humans that did not have a language. Does this show that it's built in? Well, not necessarily. It could be a cultural innovation. It could be, for instance, that language is such a good idea that every culture comes across it and develops it. Just about every culture uses some sort of utensils to eat food with, a knife and a fork, chopsticks, a spoon. This probably is not because use of eating utensils is human nature, but rather it's because this is a very useful thing that cultures discover over and over again. Well, we know that this probably is not true with regard to language. And one of the reasons we know this is because of the demonstrated case studies where a language is created within a single generation.
Although wind power plants have relatively little impact on the environment compared to, say, fossil fuel power plants, concerns have been raised over the noise that is produced by the rotor blades, visual impacts, and death of birds and bats that fly into the rotors. This is termed as avian or bat mortality. Like all mechanical systems, wind turbines produce some noise when they operate. Most of the turbine noise is masked by the sound of the wind itself, and the turbines run only when the wind blows. In recent years, though, engineers have made changes in design to reduce the noise from these wind turbines. Early model turbines are generally noisier than the most new and larger models. As wind turbines have become more efficient, more of the wind is converted into rotational torque to drive the motor that produces electricity, and less into acoustic noise. Additionally, proper sitting and right selection of insulating materials can help minimize noise impacts. Unlike most other generation technologies, wind turbines do not use combustion to generate electricity and hence don't produce any air emissions whatsoever. The only potentially toxic or hazardous materials given off are relatively small amounts of lubricating oils and hydraulic and insulating fluids. Therefore, contamination of surface or groundwater or soils is highly unlikely.
So think about the different kinds of legal strategies and standards that have been designed to control air quality in history. Well, one is land use and zoning. So thinking about how you'd segregate different land uses. So you keep the industrial facilities or the, say, the military sites away from the residential areas. So this idea of segregation or buffering land uses where you have high levels of emissions from those where people reside away from schools. This was one of the earliest forms of attempted control, and there are examples in London back in the 17th century of prohibiting certain kinds of facilities, rendering plants, or plants that produce a lot of smoke in the air from being in residential areas. Another approach to controlling air quality is the idea of setting a ceiling or an allowable emission limit. So the idea that you would, chemical by chemical, set an allowable level of contamination in the air has become really central to the way that we've thought about trying to manage our health. So have these policies been developed in a way that's precautionary to prevent significant deterioration? And as you look at the structure of the Clean Air Act, you'll see that this idea of prevention of significant deterioration is a really critical concept.
So this is about how to get information into your memory. How do you get information out? So, it's exam period. You got the stuff presumably into your head. You have to get it out. You have to retrieve it. Well, how do you do that? Well, there's retrieval cues. Retrieval cues make sense. Retrieval cues are just things that have been associated with what you're trying to remember. Retrieval cues bring things back. But it's a little bit more complicated than that. There's a more general relationship between encoding and retrieval called the compatibility principle. And what this means is you're much better to remember something in the context in which you have learnt it. And this is also known as context-dependent memory and state-dependent memory. It's illustrated by one of the strangest experiments in the history of psychology, where they had people on a boat, and then they had them scuba dive underwater, and they taught them things either on the boat or underwater, like with things that they held up. And then they tested them later, and it turns out that you'll remember it better if you're tested on it in the context in which you learn it. And it might be because then the retrieval cues help bring it back.
Now, when we talk about personality, we're talking about something else as well. We're talking about a stable trait across situations and time. It's personality if you walk around all the time angry. That'd be a stable trait. That'd be something you carry around with you, and that's what we mean by personality. Now, how do we scientifically characterize differences in personality? And it's a deep question. Any good assessment has to satisfy two conditions. One is reliability. Reliability means there is no measurement of error. And one crude way to think about reliability is a test is reliable if you can test the same person at different times and you get the same result. Reliable is something you could trust over time. Validity is that your test measures what it's supposed to measure. So validity means it's sort of a good test. Forget about how reliable it is. Does it tap what you're interested in? For example, suppose I determine your intelligence by the date of your birth. Maybe people born in January are the dumbest. People born in December are the smartest. I was born on Christmas Eve. Is that a reliable test? Yes, it's a wonderfully reliable test. I'll test you today, I'll test you tomorrow, I'll test you next year, and I'll test you the day you die. I'll get the same IQ score. Is it a valid test? It's a joke. It's absolutely not a valid test. It has nothing to do with intelligence. But you noticed these are two different things.
Can we live without water? The answer is no. Do we know how to make water? The answer is again, no. So what do we do? The United Nations Environment Program warns that the world today is faced with a water crisis that is life-threatening. Its report on water, released recently, says that unlike the energy crisis, water crisis can mean the difference between life and death. Without sustainable water management, the health of ecosystems and those who depend on them, especially people, suffer. Shortage of potable water is restricted not just to urban areas. The problem is worse in villages and hamlets where lack of water means no crops and hence no food. Currently, because of the huge demand-supply gap, there are areas where people have to do with not more than one glass of drinking water throughout the day. This is apart from contaminated water, which routinely causes outbreaks of diarrheal diseases like cholera and dysentery, typhoid, and malaria. More than 15 million children under 5 years die, and more than 1.2 billion people's health is adversely affected every year on account of unsafe drinking water. Needless to say, women and children suffer the most.
Well, creating employee well-being in the workplace is not just a case of providing free fruit for employees or designing breakout areas in their offices. No, it requires a range of other things to be in place, including effective communication, good management, and clear job design. Communication between managers and subordinates, amongst colleagues and across departments, can affect employees' well-being as well as their productivity. A high-quality work environment not only provides a joined-up approach at the company's local and national levels, but also job security, defined roles, the chance to utilize existing skills and to hone new ones. When looking to improve employee well-being, management should introduce internal activities that would benefit employees and companies in the long run, rather than focusing on easy-to-implement options which may not in fact lead to ongoing impact. Companies should make small but systematic changes to manager training, foster appropriate conditions for employees, and create opportunities for their development. In doing so, employee well-being will be promoted, people will feel valued, and they'll be more productive.
You don't think up exceptional products or services by doing a lot of market research or conducting focus groups. Customers may be able to define problems, but you have to come up with solutions. Customers may be able to suggest refinements to products. Truly innovative products have to come from within your own company. Innovation is homegrown, not the result of a poll. Innovation is about doing what delights the customer, not just satisfying the customer. It's giving the customer something they didn't expect. They can't ask for it because they can't know what it is before it is created. But sometimes, once it has been invented, customers can't imagine ever having lived without it. But you can't invent revolutionary products in a conservative environment. You have to let people think and act outside their corporate boxes, unlimited by job descriptions, corporate ladders, or organizational hierarchies. You have to create an atmosphere of innovation.